Could you open Weka? Now go and open the same data set which you had opened yesterday, which is iris. Right? So now we're going to do, yesterday we removed the class variable and we did the unsupervised k-means clustering, right? That gave us, right, if cluster overlap because 3 it was good filter, otherwise 2 was a bit, 1 was heavily loaded. But now we're actually going to do a real classification. Means we're going to build a model which is going to really transform the problem to a classification problem. Now, what do you do in a classification problem? As I said, there are possibilities of different values of the class. Now, when we want to do a classification here, one simple approach is load the file, go to classify sample, go to the classify tab, choose in classifiers in the Bayesian, you choose naive Bayes, and then you say you start. Could do that. So here you actually have a classifier which you have obtained. And you have probably looked at some vector in the bottom, which is known as confusion matrix. Confusion matrix is a very important element when you're describing the output of any classification. It describes how well your classifier has worked, in the sense that what is the number of misclassified instances, what is the number of correctly classified instances, and one you actually use this for a specific instance, it gives you even percentage of error in terms of how many root mean square error in terms of how many misclassified instances, etc. But here we have done one mistake, which is we have fitted the entire data and we have said that we will work with that data to get what we say maximum possible fitment into the current data. So, but where is the future data? Have we done any testing? No, right? So what we will usually do is, instead of running the classifier on the entire data, we usually will try to create a training data and test data separately. So go to pre-process, open file. Let's assume we're opening iris. Then we go to, when you go to pre-process, go to filter, go to filters, go to instance, go to resample, filter, instance, resample. Now here we want to create a training set out of it, which is basically saying that we want to create an 80%. So take the sample size to 80. Then make no replacement as true. Invert selection, keep it false. You got that? So why it is? Because it is in your control as to how you want to manage your. So what you want to do is you want to take the manual approach to creating your own training and test sample. That way it gives you more control instead of depending purely on the tool to have generated something in situ. So what you do is you go to resample, create an 80% sample size percent. You got it? Sample size percent 80. No replacement, make it true. Let invert selection be false. Say OK. Then when you say apply, you will see that automatically the number of instances has gone to 120, which is 80% of the 150. Now this we would like you to save as something like iris train. Okay. What did we do? We do resample with replacement equal to yes and percentage equal to 80. Then we applied, we got 120. Is it clear? Now we have a training sample. No. Did you click apply? Let me do again. So what I'll do is I will undo. Undo means I've gone to original. I'll go to resample. I'll go to invert selection false, no replacement true, 80% as sample size. Okay. And then I'll say apply. I get 120. Then I'll go and save this. But once you save this, this is 120, you saved it as train, right? Train sample. Now you have to undo it so that it will come back to 150. Got it? Now you go and resample again, but invert selection make it true. Say OK. Then apply. Then you get 30. This is the test sample. So this is what we're calling as iris test. Then you undo. Clear? Done it? You got a test sample. Once you undo, you're back to 150. Simple thing, one change, which is basically in the resample, you change the invert selection to true from the earlier one. What it does is for the same percentage, you're inverting the selection, means whichever you're selecting, you're putting in the opposite. So that way you are getting only 30 as a test sample, 120 as a train sample. So you have now two sets, iris train, iris set, iris test, both of you. Okay. Okay. So what we did was we did undo, right? You are at 150. Once you have 150 after you did undo, then you go to resample. You put invert selection equal to true. You put no replacement equal to true. Sample size percent 80 again, same. Then if you run, apply, now you can see you're getting 30. Is this clear? This one you save as test. So your indicator is basically the percentage. 20%, which is 30, is going to be a test. 80% which you got is train. So you are now training sample and a test sample, right? Okay, so now I am assuming both of you got it. Now go to classify. Now you are working with naive Bayes. What we'll say is we will use training set virtual pre-process, open file, go to the new one, which is iris train. Open the training data set. So go and open the training data set. Now you'll be working on the 120 sample. Okay. Now you open, go to classify, then say naive Bayes. You say use the training set, and then you say start. One virus data, and then run it again, and then save it. Say, let me repeat. You done original 150. Then you can just say pre-process filter. You can say supervised instance resample. In resample, you will say no replacement is true, 80%. Say OK. Then you say apply 120. You can save it. So I would suggest do it. Then one mistake you should do is you should definitely undo so that it comes back to 150. Then you go and change the invert selection to true. Then you apply. Then you get 30. This one you save as iris test 2. Okay. So now what we will do is we will open the iris train. We did that, right? We opened the iris train, which is 120. We ran the classify. We said naive Bayes. We said let's start it. Run this. So you have done this model. You created the model on the training set, right? So where is it that you have generated that equation or classifier, whatever, the internal representation of the model? That's where if you right click at the left window, you can say save the model. Could you see that here? You could save the model. saying that I can save it as a model object file. I'm saying it is iris base model I have saved. So even if you get out from the instance, you can always go, you can quit Weka, you can come back, you can load the model. But in our case, since we're continuing the session, don't worry. Now that you have created a model for the training set, because you run it on the 120, which is the training sample, right? Now you say I want to test it. And then when you're saying test, you have to open the file. I will run it on the test data which you saved. Okay, clear? Test, when you say, let me repeat again. You click that supply test set, then go to open file, set open file, and load the test one which you had created. Right? Then you say start. You're seeing that it is performing pretty okay for the test set. It's not, in fact, it's quite good. In fact, there's hardly one error, that's all. In the confusion matrix, if you see, it is working perfectly. So the model you've evaluated for the training set, in fact, it's performing better on the test set. So this is a good validation that this is a good model. You can save it and you can work with it for your future classification. So the way you typically have to work with is you have to do your own manipulation. You want to do, I did 80-20, you can do 70-30, you can try 90-10. But where you get maximum, this is a very good result for us for the test case. So you have to keep manipulating. But then there is one more angle. Let's go back to pre-process and open the original file, which is the iris dataset. Right? Now here there is another way you can do that, which is basically what we call as percentage split, where you don't have visibility into what is that percentage, what is the sample on which you're classified, what is it. You can also do this. So let's try this. Let's say we did the same thing, right, with 80-20. Let's say we talk with 80-20. So yeah, here also it's doing well. It has done well for the test. Apparently it's doing good. And so you can save this as a model too. You can save, or you can re-evaluate model on the current test set, which is the test set which you had loaded, right? Yeah, it's doing well on the 30 instances. Now let's try changing the percentage. If it changes any, let's say we start with 70. We find that the number of samples on which it tests, it's on 45 now, right? You see that, you go through the result, because you talked about 70-30. You create the model, you try to create it on the test. So whatever we did manually, right, separating testing and training, it is doing internally and creating in situ the testing sample and running on it. But what we found is 70% test is basically performing badly compared to this, because the 80% was giving much less. It was only giving one misclassified. So there are two separate ways. One is a manual approach, which I trust more because it gives you a way even to visualize what is happening. Let's take this for example. You can actually go and visualize. So you see that there are three errors. One was for versicolor. So suppose you want to visualize each variable with respect to the predicted class. If you do predicted class with predicted class, you'll naturally be a diagonal. So there's only one misclassification here, which is the one which is for this. So what you can do now, I wanted to do one thing is come out of Weka totally. I want you to show the power of the model that is saved. That's what you're going to work on. Come out of Weka, start the Weka again. Now go to Explorer. Say again you open the, let's say you open iris training sample. Now assume when you're going to classify, you can actually directly load the model which you had saved. And show it as iris based model, right? Now I want to test this on I have to choose the Bayesian classifier, right? So what I've done is now I've chosen the classifier as naive Bayes, and then I've put the test as the old test set were done, and then I've loaded the model here, you see, and then I'll say start. So I have no training sample, nothing here. I only have the saved model. Now I'm trying to test it on a test set which I had generated. See what is happening. This is what you're going to use for your prediction and predictive capability. So what you're saved is basically the model corresponding to the Bayesian classifier. Clear? No, this is going to be the routine you do for several, what do you call, supervised learning. Wherever you have created a classifier or a regression function, you will be working to get the model which you are comfortable, then you will save it, and then you will use it in the future instance. Clear? Now let me show you one other interesting thing. Let's load the original file, iris. Now if you want to do classification, let's choose naive Bayes. There is another interesting way you can do your validation, which is known as cross validation. It depends on number of folds. So what class validation does is, if you say tenfold, it creates 10 equal partitions, random partitions of the entire population. It tries to do 10 times the train test combination by taking one of the 10 partitions as test, remaining 90% of the data as train. And it rotates across all the 10 partitions like this. And then it takes the average of such a result across all the 10 validation steps. You see that when we do cross validation across a sample, we got a sample here, but it may be, I think the error is definitely not smaller than what we did with our model. But cross validation is sometimes, a lot of times, gives much better average model as compared to trying out different combinations of train test. It's a very powerful technique though. Cross validation is a very powerful statistical technique, and it's a very useful technique for us to get some measure in terms of average. Clear? Yeah. So we covered a lot of ground today in terms of the tool, the supervised learning, the Bayesian approach. That. So what we will do now is we will go to another data set and try to see how well we have done. Let us see if we open another data set, which is let us say we work on the diabetes data set. So diabetes is, again, this is a classic what we call a diagnosis kind of a problem, where you try to find out different approaches to address whether somebody is diabetic or not. Here, let us go to classify. Let's choose naive bias. Let's do cross validation. We find that the Bayesian classifier is okay, but it's not so great because we have misclassified instances as 78 and 104. Let's assume we do with percentage split something like 80-10, 80-20. It's much better, right? With the cross validation, we're getting much different. But if you're doing with cross validation of 80-20, we're getting a much, let's say we do with cross validation of 70, get much better model here. So here is another example of how you use Bayesian classifier to basically correlate whether somebody is tested positive or not tested positive. So you say he does not have diabetes or has diabetes. What are the influential variables? This is basically something related to pregnancy, plasma, skin, insulin, etc. So the idea is here you have taken multiple potential causes related to the effect, which is whether you're diabetic or not. And then you have performed a classifier based on Bayesian technique, and you have created the model. Now, what you can do is you can probably save this model as base model, and then you can use that model for future prediction. You can of course run it across several other methods. You can create 80% sample manually and then run that, all that. But what you see is cross-validation typically is giving you a lot more misclassified as compared to doing the training and testing combination. So you're probably better off in handling this in your own way of training and test combination. So there's no one specific technique you'll use in supervised learning. You have to be comfortable with what is the error you're comfortable with. It's not possible always because data is going to dictate what your ultimate goal is. But here, a model which is coming from cross-validation is probably much more incorrect in terms of classifying test instances versus the one which you do with something like train test combination. So I think what we will do is we will park the Weka for a little while. We've done enough, but what we will try to do now is we'll catch up some amount of theory related to some other classifiers.